said, this would be like my first talk after the COVID-19 thing, and I'm really glad to be part of this international community and share my research with you guys. As mentioned before, this study actually was published in Studies in Second Language Acquisition in 2018. So it's part of my research in my PhD study, but I'm trying to cover a little bit more things other than like technical details in this paper. So I'm trying to follow this outline, and just let me know if you have any questions. I'm going to start with this picture. Here is my daughter. She's just 3 months old, and she has just begun babbling a little bit, and which is really funny because I seldom pay attention to first language acquisition, but since she started babbling, I started to wonder what makes language acquisition possible. What drives language acquisition? I mean, both first language acquisition and second language acquisition. So many of you have been very familiar with Noam Chomsky and his famous universal grammar theory. According to this UG theory, language acquisition is made possible because not because of language input, but because of this universal grammar, which is innate in our brain, which is born with. So Noam Chomsky actually he did not believe in like language input. So language input cannot make language acquisition possible because he attacks this claim by saying that language input actually is poor. So this is what we the famous claim called the poverty of stimulus. But in recent years, there are also alternative theories, which I call, and other people call, usage-based approach. And I listed some of the most famous scholars, the pictures here, like Tomasello, Langacker, Goldberg, Nick Ellis, and John Bibb. So all these people, they believe actually language input can make language acquisition possible. So how? Basically, their key claim is that language input or language use is not random. They follow certain statistical patterns, and people, no matter children or adults, or no matter when learning first language or learning second language, they are able to track these statistical regularities and retrieve those patterns, which will help us to establish mental representations of linguistic units as well as the use of language. So talking about statistical regularities of language, many of you also may have been very familiar with frequency. So some words are used very commonly, other words are used less commonly, and such word frequencies follow what we call Zigfrid's law. That is, some of the most commonly used words like the and they actually account for a large proportion of language use. Whereas other words, less commonly used ones, they only account for a very limited proportion of language use. And according to Chris Shenzhen and his colleagues, there are other regularities as well, and in language use and at different levels. For example, we know there are regularities. There are certain patterns underlying which letters should go together, like W, R, I, go together and make a sound like R written. And we also know there are patterns underlying the combination of morphology, like affixes, prefixes, and suffixes. Also, there are regularities at the level of phonology and orthography. That is, which letters go together and make certain sounds, and which letters go together and map to different sounds. And also, because I'm going to talk about word combinations and multi-word sequences, we also know that there are such kind of statistical regularities as even at the level of word combinations as well. So what are multi-word sequences? Multi-word sequences are word combinations that are used frequently in our daily use of language, and they are different categories. For example, like idioms, speech formulae, proverbs, phrasal verbs, binomials, collocations. lexical bundles, and compounds. Actually, some people think compounds, they belong to this multiverse sequences thing as well. So multiverse sequences, as we can see from this slide, they are different categories, and they can be categorized following different criteria. Some people they define multiverse sequences based on what they call corpus-based approach. For example, like if a multiverse sequence is used more than 10 times per million words, then they define this word combination as what we call multiverse sequences. And also they are, apart from phrase frequency, they are another type of statistical regularities about multiple sequences, which is called contingency in my paper, and actually is also called association strength in other paper and my recent work as well. For example, what is this association strength thing? For example, if you see a word like prime, you're going to predict the next word like minister. You are able to make this prediction quite well because these two words, prime and minister, they are strongly associated with each other. And this kind of association pattern actually is going to help us to grasp the use of word combinations in many cases. And if you see this, another example like busy road, you can hardly predict what is going to take place after the word busy, as well as you can also hardly predict which word precedes the word road, because busy and road, this word combination, it is loosely associated. And so this kind of association strength or contingency information can be captured by different corpus metrics, such as mutual information, t-score, log dice, delta P, transitional probability, and they all follow this contingency table. So I'm not going to cover the technical details of how to compute these different metrics, but there are a lot of details in my paper as well as in my recent work. So to sum up, if we are going to think about the differences between UG theory and the usage-based approach, there are at least two key differences. The first thing is about the linguistic unit. UG theory, they think multiple sequences, they are generated based on words and rules. So they are not part of the mental lexicon. Except for like idioms. They thought idioms are part of the mental lexicon, but for other like more free word combinations, they think that they are not part of the mental lexicon. They are freely generated using rules and words. The other thing is universal grammar. They think like language input cannot shape language acquisition. It is not enough. It is universal grammar that drives language acquisition. It's the rule, it's the grammar. But for usage-based approach, we believe that language use actually drives language acquisition, particularly like the statistical regularities. People are able to track such kind of statistical information and use such kind of statistical information to help establish mental representations, as well as to grasp the use of language. So following these two slides, we're going to see why I'm going to focus on multiverse sequences and why I'm going to focus on statistical regularities. Because by focusing on multiverse sequences and by investigating L1 and L2 speakers' sensitivities to statistical regularities underlying multiverse sequences, we are also able to shed light on this debate like UG or UB, which theory explains language acquisition better. So this is what I want to mention here. The other thing is, as Professor Rebastrat and other researchers have examined, is what we call statistical learning. So since there are statistical regularities underlying multiple sequences, and people are able to track such kind of statistical information when processing multiple sequences, the other question is how robust is our sensitivity to statistical patterns underlying word combinations? A famous study done by Safran and his colleagues in 1996, they found like 8-month-olds are able to use transitional probabilities between underline the string, like the phonetic string, and use such kind of information to tell like the word boundaries. So a natural question is, if 8-month-olds are able to show such kind of statistical learning ability, will this ability be subject to some certain kind of maturational constraint? Will L2 speakers, adult L2 speakers, are able to track such kind of statistical information underlying multiverse sequences as well? So this is what the other point why I'm trying to do this research in this context. In recent years, there are people trying to look into cognitive aptitudes, and for example, like Kaufman in 2010, he did a structural equation modeling and find out implicit aptitude is actually an independent construct, which is quite different from other constructs such as explicit aptitude, working memory, and general intelligence. And in other SL work, for example, like Dowdy, they actually developed the high-level aptitude battery for successful language acquisition. And in their context, they also had this three-component differed, like working memory, explicit learning ability, and implicit learning ability. So by showing this slide, I'm trying to explain a little bit why I'm going to treat language aptitude into 3 different components. That is implicit aptitude, explicit aptitude, and working memory. So my research questions for this study actually comes like this. First, I want to know whether L1 and L2 speakers are able to show a sensitivity to frequency and contingency underlying multiverse sequences, specifically English collocations. And then I want to see if language aptitude are going to show any moderating effects on L1 and L2 speakers' statistical sensitivity and their collocational knowledge. By this second question, we are able to answer whether statistical learning mechanisms is subject to certain kind of like maturational construct, or whether it is robust across L1 and L2 learning. So talking about the methodology, we got like 30 English L1 speakers, 32 Chinese speakers of English, which is who were like advanced speakers of English. And I retrieved 180 English adjective noun collocations from the from the British National Corpus, and I also generated like 100 impossible word combinations as fillers. And then I used a phrasal acceptability judgment task for this experiment. In this experiment, participants are going to see like hard work and with an allowance of 4 seconds, they have to make a judgment whether this is a legal word combination in English or not. And in other cases, they are going to see illegal word combinations like popular hour, and they also have to react. And then I also used 6 different aptitude tests. So on top are 3 llama tests. Okay, the first one is what they call llama B test, which is a vocabulary learning test. You have to memorize those shapes, different shapes, and then try to memorize which shape goes to which word. And then here's also llama D test. You're going to listen in this test. You're going to listen to different sounds, different words, and then you're going to recognize which word, each word, whether it is a normal word or not a normal word. And then we also got this llama F test. In this llama F test, you're going to kind of try to figure out like the grammar patterns underlying like the input, which is different pictures. I also use return contingency task, which is like a word association task. For example, you're going to see far, and then you are going, this far thing, we're going to be associated with different word like sub, card, park, and then you are going to memorize like which word goes after like far. And I also use like operation span task. In this task is a dual task. You're going to compute the mathematics, and you are also going to memorize the word, the digits, which is inserted between different mathematical computations. So this is a working memory span task. And here we also use this serial reaction time task, which is thought to be a implicit aptitude task. So all these tasks is like this. We're going to have people to do the phrasal acceptability judgment task first, and then the aptitude tasks will be counterbalanced, and generally like this task can be done like in one session in one day. So results. I first ran a principal component analysis because we have like 6 aptitude tests. We're going to reduce it to 3 components, which is I called explicit aptitude, implicit aptitude, and working memory capacity. So as we can see in this table, llama B, llama F, and 3-term contingency tasks, they all load into explicit aptitude. Serial reaction time, they load into implicit aptitude. Operation span tasks load into working memory capacity. I dropped llama D because of its low reliability. And then let's come back to the research questions. Okay, the first question is whether L1 and L2 speakers, they show sensitivities to phrasal frequency and contingency underlying English collocations. And as we can see from this table, you can see for both L1 and L2 speakers, they show statistical sensitivities to phrase frequency and contingency while processing English collocations online during this phrasal acceptability judgment tasks. Such results are quite similar if you are going to run like the models using reaction time data or accuracy data. Then let's revisit our second research question, which is about the moderating effects of language aptitude. I'm trying to reduce this information in this whole table, but I'm going to cover the results bit by bit. Okay, so as we can see, the first thing is we are going to see statistical sensitivity is not moderated by any of these language aptitudes. So in this paper, I'm trying to examine whether statistical sensitivity to phrasal frequency and contingency is moderated by these 3 types of language aptitude. And how could we do this? I do this basically by examining the interaction between effects of phrasal frequency and contingency and language aptitude. So I didn't find any interaction between phrase frequency, contingency, and the 3 language aptitude components. So that's why I concluded that statistical sensitivity was not moderated by any of those language aptitude. So based on this finding, I concluded that statistical learning actually is quite a robust mechanism because if you think if statistical sensitivity is moderated by language aptitude, that is, if some people are more capable of learning language, then they are more likely to show this kind of statistical sensitivity. They're more able to track statistical regularities, underlying word combinations. And if you are not that capable of, say, recognizing a sound and remember words associations, then following this logic, you are also less likely to track the statistical regularities underlying word combinations. So that's a horrible thing, I think. Okay, so because the results didn't go like they'll go out like that, so it's kind of taken as evidence to support like actually everybody, no matter how old you are, no matter whether you are learning first language or second language, you are actually able to track statistical patterns underlying language input, and you are able to make use of this kind of statistical information to help you to grasp your first language or the second language. Okay, this is the first take-home message I want to show you. The second thing is about the role of implicit aptitude and explicit aptitude, as well as working memory in collocational knowledge. Okay, as we can see at the bottom here, working memory actually didn't show up any role, any effect in this phrasal acceptability judgment performance. This is quite an innovative finding because few people have tried to examine the role of working memory in the acquisition of word combinations or multi-word sequences. So I think more research can be done in this regard because such patterns, I'm not quite 100% sure about the robustness of my results. But I have a student who is currently working on this topic and trying to explore whether working memory played a role in the acquisition of multi-word sequences. But as we can see here, implicit aptitude and explicit aptitude, they do play a role, but they show different patterns. For example, if we see implicit aptitude here, we can see, if we analyze reaction time, we can see for L1 speakers who achieved higher scores in implicit aptitude test, their reaction time when judging the acceptability of multi-word sequences, they take shorter time. So it's kind of a facilitative role. But if we are going to run analysis using the accuracy data, we also see a contrasting pattern for L1 speakers. Because for L1 speakers who achieved higher scores in explicit aptitude test, this is not going to benefit them at all. This is actually going to cause them like hardships. They're going to be less accurate in making such judgments. So taking together this reaction time pattern as well as accuracy data, I'm concluding in this paper that these result patterns, they point to the possibility that L1 speakers actually they are employing implicit aptitude when acquiring or processing multi-word sequences. And I think this conclusion is consistent with the way they learn their language, their first language. As we see, L1 acquisition mostly take place without much awareness. So finding the facilitative role of implicit aptitude in the processing of English collocations should not be surprising. But if we come to L2 speakers, we find a different pattern. Okay, and the pattern was shown only when using accuracy data, and we found like for L2 speakers, if they achieved higher scores in explicit aptitude test, they are going to be more accurate when making acceptability judgments for English collocations. And I think this result is also consistent with their way of learning English collocations. As I mentioned in the demographic information about of my participants in the paper, actually the L2 participants, they all learned English in classroom settings. And in China, our English learning or teaching is famous for its, it's basically based on rote learning. You memorize, you keep memorizing, and memorizing again. So this explicit way of teaching and instructing, I think, can explain why explicit aptitude played a facilitative role for L2 speakers, but not for L1 speakers. And this also reminds me of my recent work. Recently, I carried out a meta-analysis on the topic of the processing advantage of multiverse sequences during online tasks, which is carried out with the aid of my MA students, Yanlu Zhong, which is also under review. In this research, we found like L1 speakers did not show any moderating effect of task explicitness on the processing of multiverse sequences. But for L2 speakers, we did find facilitative role of task explicitness on the processing of multiverse sequences. That is, if L2 speakers were performing tasks are performing tasks for multiverse sequences, and these tasks are more explicit, they are going to they're going to demonstrate higher levels of processing advantages for multiverse sequences relative to, say, like control phrases or novel word combinations. So this meta-analysis finding is also consistent with what we just covered here about like the facilitative role of explicit aptitude for L2 speakers, but not for L1 speakers. So to sum up, findings in this study suggest second language acquisition is indeed usage-based. So remember what I tried to talk about in the beginning of our this talk. I'm trying to set the whole story in a debate of UG, universal grammar, versus UB, the usage-based approach. And since we find like L1 and L2 speakers, they are both sensitive to statistical regularities underlying English collocations, I think this confirms that second language acquisition and first language acquisition as well takes place following this usage-based story. That is, we are able to track statistical rarities underlying language input. And such kind of statistical patterns, statistical knowledge is going to help us to learn, to acquire first language and second language. The second selling point about this study is statistical learning mechanisms are robust for L2 learning. Remember, I talked about the study by Safrin and his colleagues, the findings of 8-month-olds being able to track statistical regularities and use that kind of statistics information to detect word boundaries. And because in second language acquisition, in our field, people are always worrying about critical period and maturational constraint. So by finding that statistical sensitivities are not subject to moderating effects of language aptitude, I'm going to conclude here that statistical learning mechanisms, at least for multiverse sequences, are robust. And it is not going to be moderated by language aptitude. And it works for L2 learning, even for adults as well. The third selling point about this study is L1 and L2 speakers, they may differ in the implicitness and explicitness of their knowledge of multiverse sequences as their way of processing multiverse sequences online. As we can see in the previous slide here, we found like implicit aptitude, explicit aptitude, they play different role for L1 and L2 speakers while performing phrasal acceptability judgment tasks from English collocations. And I think with more studies in the future, we are able to consolidate this finding, and we're going to see if L1 and L2 speakers are indeed different in this respect. So thank you all. I'm going to thank my supervisor for this study, Michael Long, who passed away last year, and also other supervisors and committee members for this research, Robert Kaiser, Stephen Ross, and Dr. Nan Jiang, and also my MA student Yanlu Zhong here. So my talk ends here, and Professor Robusta, yeah, I'm ready for any open discussions.